We start with multiple choice question MCQs. For question number 1, which of the following is not a type of process scheduling? So the answer is C, priority scheduling.
Okay, so for the number 2 is what is the main goal of short-term scheduling? So the answer is C, which is deciding which process to execute next from the ready queue.
Assalamualaikum. So for the question 3, so which scheduling algorithm is known as FIFO? So we have short A, B, C, D, SPN, FCFS, RR, and HRRN. So in this three, so the answer is B, first come, first serve. Thank you.
Okay, let me start the fill in the blanks question. First, the scheduling policy that selects the process with the shortest remaining execution time is called. The answer is shortest remaining time first. As we can see, the selection function, we select the process with the shortest expected service time, and the decision mode is preemptive. Okay. Let's go for the question 2.
Okay, so my name is Aiman Syamil Shah, and today I will be presenting the assignment 3 fill in the blanks questions. So for the first question, the scheduling policy that selects the process with the shortest remaining execution time is called. So the answer is shortest remaining time, or in short form is SRTF. So SRTF picks the process with the smallest time left to complete. It is preemptive. If a new shorter job comes in, it interrupts the current process. Okay, so we move on to the second question. In a round-robin scheduling algorithm, the key parameter that determines how long a process runs before being preempted is called the. So the answer is time quantum. So time quantum or time slice is the fixed time limit given to each process. If a process doesn't finish within this time, it goes back into the queue, ensuring fairness among all processes. So for number 3, a scheduling policy that ensures the longer process do not starve by increasing their priority over time is called. So the answer is aging. So aging prevents starvation by gradually increasing the priority of waiting processes. This ensures that even long waiting or low priority process will eventually get CPU time. So that's all from me. Thank you.
The plans question number 3, a scheduling policy that ensures that longer process do not starve by increasing their priority over time is called feedback.
For the magic question, FCFS matches to processes are executed in order of arrival. Round robin matches with uses a time quantum for preemptive scheduling. SPM matches with selected the process with shorter service time. HRRN matches with selects process based on highest response ratio. Feedback matches with uses dynamic priority adjustment.
So for the subjective question, the first question is in uniprocessor scheduling, the execution of each scheduling policy is based on their selection function and decision mode. So the question is, what does it mean by selection function? So the answer is the selection function in uniprocessor scheduling refers to the criteria or rule used to choose which process should run next from the ready queue.
Subjective question. Question 1B, what does decision mode mean? And explain two types of decision mode. Decision mode in uniprocessor scheduling refers to when and how the scheduler makes decisions about switching the CPU from one process to another. It determines whether a running process can be interrupted, preempted, or must voluntarily release the CPU. Two types of decision mode is number one is preemptive decision mode. The OS can interrupt a running process to allocate the CPU to a higher priority or more urgent process. Number two is non-preemptive cooperation decision mode. The scheduler cannot interrupt a running process. The process retains the CPU until it terminates, voluntarily blocks, and explicitly yields control.
So for the question C, uh, so at the first Roman, it's first come, first serve. So we go to the selection function and decision method. So for the selection method, selects the process based on arrival time, the one that arrived first. And the decision mode, non-preemptive. When the current process ceases to execute, the longest process in the ready QE is selected. Means for the selection function, we will select the one who comes first. It means like when A comes at time 0 and B at 3, C at the 5 and D at the 7, for example. So we will go to the A. So after A, then we'll go to the B. So that is selection function, which is A come first, A go running first, and then B. Then for the decision method, when the current process execute, the longest process in the ready QE is selected. Means after A, the B is the second to wait. So is the first to wait. So after A finish, so we go to the B. So then we go to with the flow like A, B, C, D. We use who come first, then he will go first. So the next will follow the rules. Thank you.
For the shortest process next, for the selection mode in the shortest process next, it will select the process with the shortest service time. Once a process starts executing, it runs until completion. The scheduler selects the job with the shortest total CPU burst time from the ready queue. What is decision mode? It is non-preemptive. The scheduler then checks the queue and chooses the shortest job next. It does not interrupt a running process, even if a shorter job arrives in the meantime. So that is for selection. That is for shortest process next.
Okay, so my name is Aaron Azri, and in this part, I will be explaining further regarding subjective question number three. Sorry, C3, which is regarding shortest remaining time. So it's in the name. The scheduling policy will be regarding the processes with the shortest remaining time. So the selection mode is preemptive. It always runs the process with the least remaining time. If a new process arrives with a shorter time, then the currently running one, it preempts the current process. So what does this mean? So let's say process A and process B. Process A is relatively long, let's say 50 seconds, and it's already 25 seconds in the process. And then suddenly process B comes into place, which is only 10 seconds, which is shorter than the remaining amount of time for process A. So this means that the process will stop process A partially and then do process B first and then resumes process A. That's what the selection mode for shortest remaining time is. So the decision mode is whenever a new process arrives or a running process completes. The scheduler constantly evaluates remaining time to decide which process should be running at any moment. So what does this mean? So the decision mode for the shortest remaining time is the fact that it is always assessing which process is shorter than the rest. So it doesn't like work with what is currently it has in the queue. It will always evaluate whatever things come into the queue. So let's say if originally there's A, B, C, it will work with A, B, C. But when D comes into place, it will analyze A, B, C, D, and then etc. 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 It is always analyzing which one is shorter in terms of time for completion.
Okay, so now we'll explain about the highest response ratio next, or HRRN. First, let's talk about the selection mode. In HRRN, the scheduler can calculate the response ratio for each process. The process within the highest response ratio will be selected next. The response ratio is calculated using this formula. Response ratio equals to waiting time plus service time divided by service time. This formula is special because it favors two types of jobs: shorter jobs because their service time is small, which increases the ratio; longer waiting jobs because a high waiting time also increases the ratio. So using this method, the scheduler always picks the process with the highest ratio at the moment. Next, for the decision mode, HRRN is non-preemptive. This means once a process starts running, it will finish completely before the scheduler selects a new process. Only after a process finishes, the scheduler will recalculate all the response ratios and select the next highest one. In summary, HRRN helps to balance between short and long waiting jobs and always picks the jobs that has waited enough or is short enough to be fair.
Question V, Roman round robin. Selection mode is process are selected in a circular order. Each process gets a fixed time quantum. Example 50 ms and 100 ms. The decision mode is preemptive. If a process uses up its time slice, it is moved to the end of the queue, and the next process is scheduled.
For the feedback algorithm, the selection mode is processes are assigned to different queues based on their behavior. Scheduler picks from the highest priority queue first. The decision mode is preemptive. Scheduler can move a process to a lower priority queue if it uses too much CPU time. Decision happens when quantum expires, process finishes, or priority adjustment occurs.
Algorithm question. Question 1. A. For first come first serve. Draw the scheduling diagram and find the average waiting time for the process above using the scheduling algorithm below. So, to find the waiting time, how to calculate waiting time with first come first serve process is start execution time minus arrival time.
Go to the first question, which is A, first come first serve, as Hazmi has explained just now. So we go to the process A. So we see that A arrives at time 0. So it starts immediately, and it has a burst time, which is the burst is the service time equal to 5. So uh so for the finish, I mean, if you want to see the finish time, so we add these two, 0 plus 5 equal 5. So after that, we will proceed to the next process.
Okay, so for the process B, which is arrival time is 1, burst is 4, start is 5, and finish will become 5 plus 4 equal to 9.
For the first come first serve for process C, we want to know the finish time for the process C. So the start time for the process C is 9, with the burst time is 8. So we want to know the finish time. So 9 plus 8, we got the 17. For the next process, start with 17. That's it.
Okay, so now I will explain my assigned part for question A, which is first come first serve scheduling. My process is process D. It arrives at time 5 and has a service time of 6 units under first come first serve. We follow the order of arrival, so the process D starts executing after process A, B, and C have completed. So process D starts at time 17 and finishes at time 23. To calculate the waiting time for process D, waiting time equals to start time minus arrival time, which is 17 minus 5, which is equal to 12 units. Therefore, the waiting time for process D is 12 units.
So I will be explaining further regarding the first question for algorithm. First come first serve. I will be explaining specifically the part for average waiting time. So as my colleagues have previously explained, the waiting time will equal start execution time versus arrival time. So that means generally that will mean A for process A will be 0 minus 0, B 5 minus 1, C 9 minus 3, D minus 17 minus 5. You get that. You get that total divided by the total number of processes, which is 4, you will get 5.5 ms. So it's fairly simple. Average waiting time is the simplest part of the equation once you get all of the necessary information.
So for question C, explain about the selection mode and decision mode for each of the scheduling policy below. So for question V, round robin, selection mode, process are selected in a circular order. Each process gets a fixed time quantum, example 50 ms or 100 ms. Decision mode, preemptive. If a process uses up its time slice, it is moved to the end of the queue and the next process is scheduled. That's for round robin.
So Assalamualaikum. For the question B, for the process A, so the shortest process next is we will see the shortest service time, which is the first time. So for the A, it arrived at the time 0, so it will start immediately. So it has 5, which has a burst time or service time equal to 5. So we will add 0 plus 5, so we will finish at 5. So we will proceed to the next process, which is process B.
Okay, so for the question B, for the process B is arrival 1, burst 4, and start 5, which is 5 plus 4 equal to 9.
So for B, the shortest process next, how to explain for the process C. So for the process C, it start with 9 and the burst time is 6. So 9 plus 6, we know that it's to finish at 15.
So next for question B, which is shortest process, next scheduling, my process is still process D. In SPN, the process with the shortest service time is selected next from the ready queue. So process D arrives at time 5 with a service time of 6 units after process A and B are completed. Process D selected because it has a shorter service time compared to the others. Process D starts at time 9 and finishes at time 15. So to calculate the process to calculate the waiting process time for D, so the waiting time is equal to start time minus arrival time, which is equal to 9 minus 5, which is equal to 4 units. So for SPN, the waiting time for process D is 4 units.
Okay, so next for question B, I will be again explaining the average waiting time. So as stated as my uh, colleagues for this question, for the previous part of this question, again we understand that the waiting time is the total of start of execution time minus arrival time. So in this case, it will be for process A 0 minus 0, 5 minus 1, 9 minus 5, and 15 minus 3. You add it all up together and you divide it by the total number of processes, which is 4. And then you will find that you will get 5.0 on the dot.
So for shortest remaining time, question C is how to calculate waiting time. Waiting time is equal to total of start execution time minus file arrival time. So then we need to find turnaround time, which is finish time minus by arrival time. And then below of our answer is the Gantt chart, which is process A 0 until 5, process B 5 until 9, process C 9 until 15, and process D 15 until 23.
So for the process A, we want to calculate the waiting time. So it's arrived at 0. So waiting time is equal to start and arrival. So it start with 0 minus with the arrival 0, and we got the 0 for the waiting time.
Now moving to question C, which is shortest remaining time scheduling. My assigned process is process B. So process B arrives at time 1 with a service time of 4 units. According to the Gantt chart, process B starts execution after process A completes specifically from time 5 to 9. To calculate the waiting time for process B, waiting time is equal to start time minus arrival time, which is equal to 5 minus 1 and equals to 4 units. Process B finishes execution at time 9. The turnaround time is equal to equal to finish time minus arrival time, which is 9 minus 1, which is equal to 8 units. Thus, for process B, waiting time is 4 units and the turnaround time is 8 units.
Okay, so for the question C, for the process C is arrival 5, burst 6, and finish is 15. The TAT is 10. So the waiting time is 10 minus 6 equal to 4.
Okay, so next I will be explaining regarding algorithm question C for shortest remaining time. I will be explaining further regarding process D. So we are given the arrival and service time in advance. So with that, we have to find the finish, turnaround time, and waiting time. So as seen for process D, the arrival time is 3, burst is 8, finish, turnaround time is 20, and waiting time is 12. So when we get these values, so waiting time is, as you know, 20 minus 8, which is finish time minus arrival time. Eh, uh, I mean turnaround time minus burst time. So what is burst time? Um, burst time is the amount of time it takes to complete. Purely just the time. It does not count the arrival time or the finish time. It just takes the purely how long it takes to complete the process. While the turnaround time is turnaround time is the amount of time the process takes starting from the arrival to the finish. So it is finish minus arrival, the distance from that. So that's how you get 20.
In shortest remaining time, the waiting times for each processes are A 1 unit, B 0 units, C 12 units, D 4 units. To find the average waiting time, we have to add all of the time units of all the processes divided by the amount of processes. So the average waiting time is 1 plus 0 plus 12 plus 4 over 4, which is 4.25 units.
So for question D, highest response mentioned next. So waiting time is total of start execution time minus by arrival time, and the ratio is waiting time minus by service time, and the total of each divided by service time. So for the calculation for process B is 5 minus 1 plus 4, the total of it divided by 4, and the answer for process B is equal to 2.0. So then for process C, 5 minus 3 plus 8, and the total of it minus by 8, and it will come out with 1.25. And process E, 5 minus 5 plus 6, and the total of it minus by 6, and it will outcome with answer 1.0. And then we compare with BCD. B have 2.0, C have 1.2.5, and D is 1.0. Process B has the highest ratio, therefore B is big. Then we calculate again process C. 9 minus 3 plus 8, the total of 8 divided by 8, and the answer will be 1.75. And process D, 9 minus 5 plus 6, and total of 8 divided by 6, and it will come with answer 1.66. Therefore, the process C has the highest ratio as it have 1.75 more than 1.66. Therefore, C is bigger. Thanks.
So for the question D, the process A is arrival time is 0, service time is 5, start time is 0, and the waiting time is 0.
For the highest response ratio next, at the time when process A finishes at time 5, process B and C are waiting. To calculate the response ratio for B, we have to add the waiting time and the service time over the service time. So for response ratio of B, it is 4 plus 4 over 4, which is 2. Since B has the highest response ratio, process B is selected next.
Okay, so now I will be explaining regarding algorithm question D, which is the highest response ratio next. So in the question, waiting time is not important for my part of the question. So we have to calculate the ratio for my part of the question. So how do we calculate the ratio? Ratio is waiting time minus service time divided by service time. So how do we calculate the waiting time? We take the end time of the previous process, and then we minus it with the arrival time of the process which we want to calculate. So in this case, the first process before anything happens is process A, which is the arrival time is 0 and the start time is 0. However, the service time is 5. So it means that the end time is 5 for process A. So we take that 5 and then we minus with the arrival time of all of the processes. In my case, it is 3, so it's 5 minus 3 plus 8, which is the service time for C, divided by 8. So you get 1.25. So in the first part of the question, you have to display all of the ratios for all of the processes first, and you choose the highest ratio to be done after A. So in this case, it is B. So B is selected to be after A. So then we drag off the other two, which is C and D, to the next part of the equation. So under there, C, we have to recalculate. So 9 is after the end time of B. So 9 minus 3, which is the arrival time of C, you redo it. Then you plus by 8, which is the service time of C, divided by the 8, which is the service time of C. You will get 1.75, making C the highest ratio. Therefore, C is picked for the next part of the Q. So it will be A, B, C, D. That is essentially my part of question D.
So for the highest response ratio next, I will explain about the process D. So we know that the waiting time start execution minus with arrival time. So it start with 17. We minus with arrive at 5. So we minus it and we got the waiting time equal to 12.
Now I will explain how we calculate the average waiting time for the highest response ratio next RRN scheduling. First, we find the waiting time for each process by using the formula start time minus arrival time. For process A, the waiting time is 0 minus 0, which equals to 0. For process B, it is 5 minus 1, which is equals to 4. For process C, it is 9 minus 3, which is equal to 6. And for process D, it is 17 minus 5, which is equal to 12. Next, we add up all the waiting times. 0 plus 4 plus 6 plus 12 is equal to 22. Finally, since there are 4 processes, we divide 22 by 4 and we get 5.5 milliseconds. Therefore, the average waiting time for HRRN scheduling is 5.5 milliseconds.
So for the round robin, so for this question, we got the time quantum equal to 2. So for the time 0, we got the ready is A at 0. So we run the 0 and the service time for A is 3. And we got the B for 4 and C for 8 and D for 6. So at the time 2, we got the ready is B and A. So we run the B and the service time if A equal to 3 and B equal to 2. And for the time equal to 4, we got the ready is A, C, and B. So we run the A because A comes first. That is A equal to 1, B equal to 2, and C equal to 8. So we run the A. Okay, let's start with the round robin for question A. So we got the time quantum equal to 2. So for the time is equal to 0. So we got the ready is A. So for the service time, we got A equal to 3, B equal to 4, C equal to 8, and D equal to 6. So as the first, we got first come first serve. So A equal to 3, we run the A. So at the time 2, we got the ready is B and A. So as the service time, we got A equal to 3 and B equal to 2. So first come first serve. B come first, we run the B first. So time 4, we got the ready is A, C, and B. So A equal to 1, B equal to 2, C equal to 8. And A come first because A is the short. A equal to 1, so we run the A.
Next, in question E, which is round robin scheduling with a time quantum of 2 units. My part is to explain the execution at time 6 and time 8. At time 6, my process is selected and runs for 2 times unit until time 8. After that, the CPU switches to the next process because the time quantum is used up. This shows how round robin scheduling ensures fair CPU sharing by time slices.
Okay, so I will be explaining for question E, round robin, time quantum equals to 2. So specifically, I will be explaining the time for 10 and 11. So when you look at the ready, what does ready mean? Ready means that the processes in the case of 10, D, A, C, which of these processes are ready to run. So running shows which of the processes are currently being undergone, and then the service times for A, B, C, and D. So when it says A equals to 0, it means that after time 10, at the end of time 10, and at the start of time 11, A is already completed and removed from the queue. That's why in for the time 11, the ready is only D and C. So as you can see in 11, for running it's D, and then it shows that D equals to 4 at the end of 11 because initially the time for D to be completed is 6 and the quantum is 2, so 6 minus 2 becomes 4. So at the end of 11, D equals to 4, which and it is still inside the queue for the next process. So that's all for my part. My colleagues will explain the rest.
For the round robin, at time 13, process C starts running. It has 6 units left before. And at time 15, process D starts running. Process C gets interrupted after 2 time units. Thus, at 13, running C, and at 50, running D.
Okay, so for the time is 17, the ready is CD, the running is C, and the service time equal to C equal to 2. So next is the time is 19, ready is DC, running is D, and the service time is D equal to 0.
Here we go to the process E, which is the process 21 and 23. So for the process 21 and 23, we see the table. So for the 21, only process C is ready, which is it's the only left, and it will automatically become the only one running. So after we have at here, we can see it has 2 remaining service time. But after we already subtract with the time quantum 2, so the service time available becomes 0. So at the 23, at the time 23, all the process is already done and there's no process really. So thank you.
For question C, shortest remaining time. To find our waiting time, we need to calculate total of start execution time minus by arrival time, and then we need to calculate turnaround time, which is we need to calculate finish time minus arrival time to get turnaround time.
For the feedback algorithm, the following priority queue is given: RQ1, time quantum 2, RQ2 with time quantum 1, RQ3 with time quantum 1. The first step is to find the waiting time formula. The waiting time formula is completion time minus arrival time minus service time.
Step 2 to find completion time. So we go to the process A, arrive at time 0. So if you go to RQ1, so when go to RQ1, will it run at maximum of 2 minutes. So at time 2, it has used 2 minutes of its 5 minutes total. So it's not finished. Then we go to the RQ2. The process will go to RQ2 and runs to its maximum 1 minutes as stated at here. And at time 3, it has used 3 minutes total. We will add the total at the last. But after that, it still has not done. So it goes to the last one, which is the RQ3. So in this line, you will keep getting 1 minute turns until it's fully done. And I think it needs 2 more minutes. So while A is in these lines, the other tasks are also arriving, which is the B, C, and D. But it will run according to the priorities. So and the last time we will get the completion time as the minutes 11. So for the process B, after that, at the process B, it will arrive at time 1. So after it arrive at time 1, let me see. Then goes as usual to the RQ1 first. So at this RQ1, at time 2, it has used one of its 4 minutes. So this one of 4 minutes. So it moved to the next line, which is RQ2, and RQ2 will run for 1 minute. Now it has used 2 minutes. So then we'll go to the RQ3. When go to the RQ3, it will also get 1 minute turns, and it still needs 2 more minutes. Against while B is waiting and running, the process C and D also be running according to the priority. So task B will finish at time 10. So I'll pass to the next person for the process C and D. Thank you.
So for the question F, the step 2, process C, the arrival time is 3, service time is 8, and the completion time is 23. So for process D, arrival time is 5, service time is 6, and the completion time is 21.
Okay, for the step 3, we want to calculate waiting time. So waiting time equal to completion time minus arrival time minus service time. So for the process 1, answer is 6 for process 1. So completion time is 11 and arrival is arrived at 0 and its service time is 5. So 11 minus 0 minus 5 and the waiting time is 6. So for the process 2, we got the completion time is 10, arrival time is 1, service time is 4. So 10 minus 1 minus 4, and we got waiting time is 5.
Lastly, for question F, which is feedback scheduling, I am assigned for step 3, specifically process 3 and process 4. In feedback scheduling, processes are moved to different priority queues based on how much CPU time they use. For step 3, process 3 and 4, it means that the process that still needs CPU time after previous steps will be moved to a lower priority queues. These methods ensure that short processes are quickly completed, while longer processes are gradually downgraded in priority so that the system remains fair and responsive.
Highest response ratio next. To calculate the question. So B, we need to minus 5 minus 1 plus 4. And then the total of it divide by 4 and we can get the 2.0. And then for process C, 5 minus by 3. And then we add 8. And the total of it we divide by 8 to get 1.25. And then for D, for process D, 5 minus 5 plus 6. The total of it we need to divide by 6. And then we get 1.0. Process B, from process B, C, D, process B has the highest ratio. Therefore, B is peak. And then we go again, process C, 9 minus 3 plus 8 and divide by 8 is equal to 1.75. And process D, 9 minus 5 plus C, 6. And the total of it, we divide by 6. And then we get the answer 1.66. So from process C and process D, process C has the highest ratio. Therefore, C is peak.
Okay, so for the final part of our assignment 3, I will be explaining the final answer for question E, if I'm not mistaken. F, sorry, F for feedback. So as stated as my colleagues regarding the previous explanation of this question, the final answer will be equivalent to the average waiting time, which is equal to 5 units. That comes from getting the total amount of waiting time divided by the number of total processes. And that's it. Easy average waiting time is, I guess that's just the answer. Thank you very much for listening to our presentation.